Welcome to Brain Vision.
We'll carry out the usual integration. And this integral will equal 1. So here we have the wave function psi of x equals b e to the minus m omega over 2 h bar x squared. And we have squared this wave function in this integral. Now, we have to evaluate this integral, and this can be obtained from a table of integrals. There is a method to evaluate this integral. This is the Gaussian integral. And we won't actually carry out that method here. I simply will refer you to a table of integrals. But this is an integral of the form or integral from minus infinity to positive infinity of e to the negative a x squared dx. And just know that the result of this integral is the square root of pi over a. And that is the result if you're integrating from negative infinity to positive infinity. If you're only integrating from 0 to infinity, you would divide by 2 on the right-hand side. So continuing, we will note that in our case, a is equal to m omega over h bar. And so therefore, our integral is equal to h bar with a pi, actually pi h bar over m omega square root. And so b squared has to equal the inverse of this. In order to give us the correct normalization. And therefore, b must equal m omega over pi h bar to the 1/4. We have to take the square root of a square root, and that gives us the 1/4 root, or to the 1/4 power. Now, what we would like to do is calculate a probability over a small interval. This small interval has a length delta, so therefore we're going to calculate over the interval delta, but we're going to calculate from delta minus delta over 2 to positive delta over 2. And now that we know what b is, we can square it, and we can just write that square as m omega over pi h bar to the 1/2 power. Normally, we would just write this as an integral. And we will set it up as an integral, but then we will make an observation that will be important. So again, this is the integral of negative m omega over h bar x squared dx. But in the limit, as delta gets very small, we don't actually have to take an integral. This is the important observation. We simply have to multiply by the interval and evaluate the function at the midpoint of the interval. So what that means here is we just go ahead and multiply by any constants we have, which in this case is the normalization constant squared. And then we multiply by the function evaluated at the midpoint. This means that we have e to the minus 0, because the midpoint is at x equal to 0. That is the midpoint of the interval from minus delta over 2 to delta over 2. The midpoint would just be at x equal to 0. And now we need to multiply this by the length of the interval. So that will be delta over 2 minus negative delta over 2. And that gives us a total length of delta. So now what we have is m omega over pi h bar, and we can go ahead and place this under a square root times delta. And that is the probability that we want. And that is the final result.